Okay, so for the last problem here, we are looking at a sys-tick timer question. So we have some code here that initializes FIO_dir. It says we're going to use pin 1.31 to light up an LED and then sort of toggle that value. If we look at the rest of the code here, we're going to, in our sys-tick handler, we get the control register to just unset the flag, unset the interrupt, which we do that by just reading this STCTRL register in the sys-tick timer. And then we're just toggling with an XOR here. So we're just toggling this value every sys-tick number of seconds. So the question is, while the program is running, will we see the desired result, which is a 50% duty cycle square wave with a frequency of 2.5 hertz on that pin. So we want to figure out what the actual timing of this timer is. And it says we can assume that all of the pointer addresses are correct. So we can just sort of take the registers at name value. So let's look at our sys-tick init. We can see that this is just setting up the registers. So again, we'll take those at face value. So really all we need to look at are these values here. So we disable the timer, we set the reload value, we write anything to that register to clear it, and then we enable the timer. So keep in mind, for sys-tick, the time for the timer is equal to 1 plus ST reload times 1 over the clock frequency. And in this case, our clock frequency is still the 100 megahertz that we've had in previous problems. So our time is going to be equal to 1 plus ST reload, which we're going to get in a second here, times 1 over 100 times 10 to the 6th. So what is our value for ST reload? Well, let's look at this, and let's convert that value into hex. So 1999999 in decimal. Let me make sure I got the right number down. It's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, and then a 1. In hex, this is going to be OX01312 CFF. So here we have to remember that the sys-tick timer is a 24-bit reload value. So only the 312 CFF part is actually going to be used as the timer. So that 01 that makes it equal to 199999999 is going to be discarded. So we're actually not going to have a good portion of this timer. So if we convert OX312 CFF into decimal, we're going to get 3222783. So that's the actual value of the sys-tick timer for ST reload. Not the value that's sort of shown at face here, because that's too big to fit into 24 bits. So we can do this with ST reload as 3222783, and if we push that calculation through, this should come out to 0.032 seconds, or approximately 32.2 milliseconds. So what we would actually see on our value here is that we would have 32 seconds on, or 32 milliseconds on, 32 milliseconds off. And if we draw the the period here, period, duty cycle there, we'd have 50% duty cycle, but it would be at 32.2 milliseconds, and then this would be 64.4 milliseconds for the period. So we're looking at how that light is on and off. It would be 50% duty cycle, but not at the time that we expected it to be. Had we just done the math with the 1999999 and used that as our ST reload, that would have actually given us the period that we expected. But again, here the trick is that this value is too large for 24 bits, which are just the last 6 hexadecimal digits. So we can't actually fit that in the sys-tick timer. Okay, so I hope this helps. Good luck with the exam.